Hi, today I'm going to present the chapter 2.6 Periodic Trends of Elements. But first, let me introduce myself. My name is Nur Umaymah binti Yunus. I'm from Group 3. Here is the information of myself. Let's get started. The introduction of this subtopic. Scientists have identified 19 naturally occurring elements and created about 28 others. The elements alone or in combination make up our bodies, our world, our sun, in fact, the entire universe. The elements were discovered since the ancient times, and there are also some elements that are still in the research. This is a table of the periodic elements and the time when the elements were discovered. This is the latest periodic table of elements filled with the latest elements that have just been discovered. There are some important group names in periodic table that we should remember. Group 1, alkaline metals. Group 2, alkaline earth metals. Group 3 until 11, transition metals. Group 17, halogens. Group 18, noble gases. Group 1, Group 2, and Group 17 are very reactive. Meanwhile, Group 18 is not reactive and very stable. Electronic configuration. Generally, the periodic table can be divided into four major regions which called blocks: S block, P block, D block, and F block, based on their electronic configurations. First one, the S block. The S block is occupied by elements with a half-filled or completely filled outermost s orbitals. Having configurations of ns1 at the group 1, these elements are metals except hydrogens, also known as alkali metals. The next group in S block is group 2, comprised of elements with a completely filled outermost s orbital, ns2, also known as alkaline earth metals. The second, the p block. The p block elements are elements that have electrons in the outermost p orbitals. The valence electronic configuration varies from ns2 and p1, group 13 to ns2 and p6, group 18. Consists of metals, metalloids, and nonmetals. Group 17 known as halogens and group 18 known as noble gases. The third one, the d block. The d-block elements are called the transition elements which have partially filled or completely filled d orbitals, d1 to d10. The f-block. The f-block is known as the inner transition element. The first row elements are called lanthanides and second row is called actinides. These are also elements known as rare earth elements. This table shows the electronic configuration in the periodic table. Next, the periodic table also can show the cation and anion of representative elements. Electronegativity is the ability of atom to attract electron towards itself in a covalent bond. The higher the associated electronegativity number, the more an element or compound attracts electron towards it. In the periodic table, across the period of element, electronegativity increases. As you go across the group, the nucleus contains one more proton each element over, so more proton means more power to attract electrons. Down a group, electronegativity decreases. This is because the atomic number increases down a group, and thus there is an increased distance between the valence electron and nucleus, or a greater atomic radius, thus less power to attract electron. The ionization energy. First ionization energy requires to remove the outermost or the highest energy electron from the gaseous atom. Second, ionization energy requires to remove any subsequent high energy electron from a gaseous cation. This process is endothermic and energy must be supplied to remove electron which is attracted to the positive charge of the nucleus. In the periodic table, from left to right of periodic table, the atomic size decreases. The outer E negative are more closely attracted to the nucleus and thus are more difficult to be removed. The ionization energy increases across the period. Ionization energy down a group in the periodic table, the ionization energy decreases. The atomic radius increases as we go down the group. The atomic size expands as more E negative are added to the successive energy level. Shielding effect increases. The outer E negative is far from nucleus and less attraction to its nucleus, thus easier to remove the electron. Electron affinity is the negative of the energy change that occurs when the electron is accepted by an atom in the gaseous state to form an anion. The more negative the electron affinity, the greater the tendency of the atom to accept an electron. Electron affinity generally increases across a period in the periodic table and decreases down the group. Electron affinity follows the trend of electronegativity. As the conclusion, periodic table has been compiled based on the atomic radius, electron affinity, ionization energy, metallics and non-metallics character. I guess that's all from me. Thank you so much for your time.